Hello everyone, my name is Horace, and in this video we're going to be going through LeetCode number 34, find first and last position of element in sorted array. So for this problem, we're given an array of integers nums, and this is sorted in non-decreasing order. We have to find the starting and ending positions of a given target value. If target is not found in the array, we just have to return -1, -1, and the algorithm that we write has to have a runtime complexity of big O of log n. So with that being said, we can take a look at an example to understand the problem more clearly. So let's say we're given this array of integers, and we're also given a target which is equal to 8. So if we want to find the first and last elements, we have to return the first element of 8 or its occurrence. So this is going to be at index 5, and the last occurrence of 8, which is going to be at index 6. So the return for the entire algorithm is going to be 5, 6. So thinking about an algorithm that we can develop to solve this problem, we already know that we have to write an algorithm in big O of log n time. So simply traversing the array using pointers is not going to be a valid solution, since that's going to take big O of n time. So the fact that this is going to be big O log n, worst case, we know that we might be able to use binary search. We already know that the array is going to be in non-decreasing order, so this is a perfect candidate to use binary search. So how can we use binary search to locate two different items or elements in the array? The first is going to be the first occurrence, and the second is going to be the last occurrence of the element 8. Well, we can use two binary searches, and each one will find one of the respective values. So let's start with some binary search algorithm, and it'll become more clear as we go through it. Let's initialize the left pointer and the right pointer. Then, like with any binary search, we find the middle element. The middle element is going to be at index 3. And we check to see if this value is less than the target. If it is, then we know that the element is going to be on the right side of the midpoint. If it's not, we know that it's going to be on the left side of the midpoint. And let's say we found the element at the midpoint itself. Well, we still want to reduce the right pointer, and I'll show you why. It's because we're going to, in the end, return the left pointer. So this case, 7 is less than 8, so we have to shift the left pointer to be mid plus 1. So the left pointer is now at index 4. Then we perform binary search again. The middle point is now at 8. So this is exactly equal to the target. But since we want to, in the end, return the left pointer, we have to reduce the right pointer because it's going to end up at the first occurrence. So the right pointer is going to be equal to the midpoint. So we can remove the mid pointer and say that the mid is now the right pointer. So the midpoint is going to be at 7. And since 7 is less than 8, we have to shift the left pointer to be mid plus 1. So we can remove the left pointer, and it becomes at index 5. but now the left pointer and the right pointer have crossed. So we can end our binary search, and look at that, we are at the first occurrence of 8 in the array. So we can store this value when we call binary search, and we can call it left. And left is going to have reference to this value here, or the index. So in this case, it's going to be 5. Okay, now that we have done one iteration of the binary search, we can do it again, and this time we want to find the last element. But how can we get the value at the end very easily? Well, we can just look to the next value in the array, and we can see if that exists, and if it doesn't, the left pointer will be there regardless. So once we find one element larger than the target one, we can find that and then just decrement by 1 to get the last occurrence of this target. And I'll show you what I mean by this. So when we call binary search, what we're really looking for is 8 plus 1. So this is going to be 9 that we're looking for. So we can perform binary search. We find the midpoint, and the midpoint is 7. So 7 is less than 9. So we shift the left pointer to be mid plus 1. Then again, we find the mid, 8. 8 is less than 9. So we shift the left pointer again. Then we find the midpoint again. It's 8 again, so it's less than 9, and then we shift the left pointer. Now see that the left and right pointers have crossed, so we end our binary search, and look, the left pointer is exactly 1 more than the last occurrence of the target value that we needed. So we can store this value at the left pointer as right. And this is going to be the value that we get, 7 minus 1, which is going to be 6. And this is exactly the last element that occurred for the number 8. So now that we have both the left value and the right value, well, we can just return that in some array. And this is only going to be returned if a left is less than or equal to the right value. And if it's not, we know that something went wrong. The element was not able to be found. So in this case, we return -1, -1. And because we're using only binary search 2 times, the time complexity is just going to be big O of a log n as required. And the space complexity is just big O of 1. We're just using pointers in binary search, so this should be pretty straightforward. With that being said, we can go ahead and write the code on LeetCode. Okay, we're on LeetCode, and we can start writing the algorithm to find the first and last occurrences of the target and then return their indices. So we can start by writing a binary search function, and this is because we're going to be calling it twice, so it doesn't make sense to write the same code twice. We'll just condense it into one function and call that function twice. So we can say binary search. This is going to take some value and we'll call it targets. So we can initialize the left and the right pointers. We can say left and right is going to be 0 and the length of nums. Then we can have a condition while the left pointer is less than the right pointer. We want the binary search to continue, so we can calculate the midpoint, which is going to be L plus R, and integer division by 2 to get the midpoints. We want to check if the midpoint is less than the target. So if the nums and mid value is less than the target, if it is, we want to shift the left pointer to be mid plus 1. But in every other case, we just want the right pointer to be equal to the mid. and then we can just return the left pointer at the end as we discussed in our explanation. Then we can calculate the left value. So left value is going to be binary search, and we're going to call it with the target value. And then the right value is going to be binary search target plus 1 to get one more, but this is going to return the next largest index, so we just want to minus 1. Then we want to verify if this is a valid solution. So if left is less than or equal to right, then we can return the left and the right value. Otherwise, we can just return -1 and -1. So this is the solution. It's quite straightforward. You just have to know how to use the binary search and change it up to get the first and last elements. So we can go ahead and submit this, and hopefully it's accepted. And you can see that the code is accepted and it runs very quickly. And this is the optimal solution, running in big O of log n time with a space complexity of big O of 1. So hopefully this video helped you and you learned something, and I'll see you soon.